Hi everybody, it's Saltash Maths Tutor, and today we're going to be covering the difference of two squares, and this is all to do with quadratics. And just to reiterate before we go any further, what is quadratic expression? It's anything to the power of 2, so or any term within the expression which is the power of 2. So x squared, well, that's the term, and it's to the power of 2, so that's a quadratic expression. And how about 4y squared plus 3y? Well, we've got a term in here. There's the term, the y term, and it's to the power of 2, so that's a quadratic expression. And it's anything like that, basically. Anything that has a term which is the power of 2. A term which is the power of 2. So now I'm going to talk about the difference of two squares, and this is a special case within quadratics, which is fairly easy to do as long as you know some of the rules to it. In fact, there's only really one rule and one thing you need to know. First thing you need to know is the squares of numbers. So you need to know, for instance, what the square of 6 is, what the square of 7 is, 10, blah 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 blah. And you need to know that there is a general formula which is x squared minus a squared. And what that gives you is, and this is you doing the factorising bit straight away, is it gives you x plus a, x minus a. But here's the small health warning, everybody. X squared plus a squared, if you see a formula in that format, does not, or you cannot apply the difference of two squares. So I stress again, if you see the plus bit here rather than this minus, you cannot apply the difference of two squares. Okay? So here's the, I've just put that difference of two squares formula up again, and let's have a look at an example, because the example, it will hopefully just become really obvious to you. So here we go, the example is x squared minus 9. Can I use the difference of two squares to factorise this particular quadratic? And remember, quadratic being a term with a square in it, yep, so that all fits. Well, does, and here's the question, can I apply this formula to this? Well, the answer is yes, I can, because if I look at it, I can see that, well, the x squared and the x squared are the same, and a squared and 9, is there any relationship between that? Well, yes, there is, because I could rewrite this formula here as x squared minus, and this is where you need to know your squared numbers, is 3 squared, and I'm hoping that that's just popped out for you straight away. Now that I've got it in this format here, what that means is that I can directly translate it, and I don't need to think about it even, I just bang it straight into this bit up here. So therefore it becomes x plus 3 x minus 3. And then to complete this, all I need to do is find out the values of x. And again, just to, this is a general revision for all quadratic equations. If I've got, oh, that's really rubbish, isn't it? Let's have that line there and that line there. If I've got a graph, I don't know what x squared minus 9 will look like. I'm just going to sort of make it up, but let's just say it looks like something like that. That's if I plotted the graph. In factorising, I'm finding the value of when the line crosses here. Remember, that's the x and that's the y bit of the graph. So really what we're saying is that, what's this value? What's the value when y equals, well, what's that line? That line, x has a value. X looks like it's going to be an x is a minus number and a positive number, but what's the y value? Well, it must be positive values here down, 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 and at that point there y equals 0, because then y takes on negative values when it goes down here. So let's get rid of that. And that's what you're trying to find. You're trying to find the values of when the equation effectively becomes 0, and you can sort of think of it in terms of that. You can add that on the end. So to make this bit here 0, it can either be that value is 0 or that value is 0, because remember, anything times 0, anything times nothing. If I've got 20 nothings, what have I got? I've still got nothing. Anyway, the value of that to make that 0 would be, well, that would have to be, x would have to be minus 3. Minus 3 plus 3 is 0. And in this side, it would be plus 3. Because plus 3 minus 3 is 0 as well. And those are the two values that you want. X equals minus 3 and x equals plus 3. The key thing that I want you to recognise though is that we've got this bit of formula up here, that it has to be a negative, and this would be an example of it. So just another quick example, y squared minus 49. Don't get thrown by the y, everybody. It's still fundamentally the same as this. I'm just changing the x's for y's, that's all I'm doing. So can I translate this into something that looks like this? Yes, I can, because I've got y squared. That tallies with that, and I've got 49 here. And in the same way as I did that, I can say that's the same as minus 7 squared, which means that I can therefore convert that straight into something that looks like that. And because I've identified, if you like, I've identified the a value. That's the a squared value that was just up there. So to rewrite that, that would be y plus 7, y minus 7. So the values of y would be y equals minus 7, that's that value from there, and y equals plus 7, which would be that value there, making both of these zeros. Okay, that's it everybody, just a very quick revision of difference of two squares. There are, off the top of my head, 3 more videos coming, which will be the other ways of factorising. Hope that's been of help, and again, if you need anything, just post comments, add it to your playlists, and thank you very much. Goodbye.